Hello, MS students of microeconomics too in IBA. This is the promised screencast of for supporting the lecture on the Slutsky equation that we did in class. I have divided this discussion into three parts. In the first part, I will give you a classification of goods into in normal and inferior, and in good, good, and bad good. And then in the second part, we will look into the decomposition of the price effect into income and substitution effect. In the third segment, we carry this discussion of the decomposition of the price effect to arrive at a result that is known as the Slutsky equation. So remember that we identify or say classify goods as inferior good and good and normal goods. So this is one way of classifying the goods that consumer consumes, and that this classification is based on income. We'll see shortly. Second way of classifying goods is to classify them as good good and bad good, and that this classification is totally based upon the preferences. And after we have discussed these concepts of normal and inferior good, we'll see that what good good and bad goods actually are. So coming to the first classification, that goods are classified as normal and inferior good. It is like asking the question that how the consumption of a good is changing, like for example change in the consumption of good I following a change in income. Two possibilities are there. The first possibility is that as income increases, that is, if this change is greater than zero, then consumption of the good in question also increases, so that this change is also greater than zero. And this means that these two changes are moving in the same direction. And if income decreases, so that this change is less than zero, and side by side consumption of this good decreases as well. This change is also less than zero. So what we see here is that these two changes move in the same direction. Either both of them are simultaneously positive or both of them are simultaneously negative. And it is because of this reason that if we take this ratio delta xi over delta m, this either see that in the case of delta x and delta m greater than 0, this will be positive as well as this will be positive, and so this ratio will be positive. On the other hand, if like for example when change in income is less than 0, that is if income decreases, then we observe side by side that the consumption of the good in question also decreases. Then this means that both the numerator and denominator are less than 0. Again the ratio will be positive. Minus minus will be cancelling out. In terms of the demand function, what we are trying to say is that normal goods are the goods of such that if we take the derivative of its demand function with respect to income, so this derivative must be greater than 0. And this is something that is true for normal goods. Um, on the other hand, if the things are a little bit different, for example, suppose that when income decreased, so that the change in income was less than zero, and we observed that the consumption of the good increases, so that the change in consumption was greater than zero, and on the other hand, if we observe that income increases, and that as a result we observe that the change in consumption is less than zero, then this means that these two changes are moving in opposite direction. If this is negative, then this is positive, and if this is positive, so then this is negative. So one of these two, denominator or numerator, is less than 0 and the other one is greater than 0, so the ratio is going to be negative. And this is like saying that this derivative dava xi over dava m is less than 0, and this is something that tells us that the good in question is an inferior good. In words, if increase in income causes the consumption of a good to increase, and a decrease in income causes the consumption of the good to decrease, then the good is a normal good. And if an increase in income causes a decrease in consumption of a good, and a decrease in income causes an increase in consumption of a good, then the good is known as the inferior good. So this is something that is like giving us the classification of goods into normal good and the inferior good. See that in this first graph I have drawn these three budget lines with the lowest income being represented by the yellow budget line. And suppose that initially this is our income level, and we are like consuming say x1 units of good 1, and so this is your equilibrium at point E1. The tangency condition is satisfied. Suppose that now income increases, and the budget line becomes the one represented by the red one, and that here suppose that the tangency occurs at point E2, and this is like saying that as income increases, consumption of good 1 increases from x1 to x2, and similarly here to x3. For further increase in income, we still observe an increase in consumption of good 1, and so we are here. And we see that with the increase in income, consumption of good 1 increases, so that this derivative dava x1 over dava m is greater than 0. So if we were moving from smaller incomes to larger income, then we were moving from the consumption of good 1 as x1 to x2 and x2 to x3. So as income increases starting from E1, consumption of good 1 increases. If we had started with E3 in the reverse direction, so that we were having initially a higher level of income, the equilibrium represented by E3, and then income falls and we arrive at E2, and income falls further, we arrive at E1, and then see that the consumption of good 1 will be decreasing. So with the increase in income, consumption of good 1 increases, and with the decrease in income, consumption of good 1 decreases. The derivative of the demand function for good 1 with respect to income is greater than 0, and so we classify x1 as a normal good. In this particular example, note that good 2 is also a normal good because at a lower level of income, we had x to 1 units of good 2 being consumed, and that when income increases, so that we move to a higher budget line, the person's consumption of good 2 increases to x22 and finally to x23. So this is a example where we see that both good 1 and good 2 are, are normal. And in this graph, if we take these tangency points with each income level and connect them by a curve, then this curve actually is often known as the income expansion path, so representing all the combinations of goods that the household is consuming at different levels of income, keeping other things constant. So no prices are not changing. Now, if suppose that the things were a little bit different. Suppose that the things were as follows. Let me first erase these old figures. Right. Suppose that the things were initially as follows. Initially, we were at point E1, like here, and consumption of good 1 was at x11 when the income was smaller, and let's suppose that when income increased, we arrived at E2, where now this difference curve which is tangent to the new budget line. So moving from E1 to E2, what happens is that the consumption of good 1 decreases from say x11 to x10, and this is like saying that change in income and change in consumption of good 1 are moving in opposite direction. If we connect these tangency points this time, so see that the income expansion path will be becoming negatively sloped, and this is something that is like indicating that one of the good is inferior good. Inferior in the sense that as income increases, we like to consume less of the inferior good. You may think in terms of the changes in the quality of food when your income is increasing. Your quality of food, you start consuming better quality of food, and inferior quality of food is the consumption of inferior quality of food decreases as the income increases, and that of the better quality of food increases. Here we see that good 2's consumption is still increasing. When we move from point E1 to E2, consumption of good 1 has gone down, but consumption of good 2 has increased. So good 2 is normal and good 1 is inferior. So they see that this is the case where one of the good is normal, the other is inferior. Remember that in a two commodity world, it is not possible for both goods to be inferior goods, and you should try to justify this statement that why this might be the so. This might be so. You may justify this thing by using some of the assumptions that we had made about the preferences in the earlier classes. So this is the classification into normal and inferior good, and see that as I told you that it is based on income. Now see that if I again write this derivative dava xi over dava m, that is derivative of the marginal demand function for ith good with respect to income, and that if I multiply this uh, derivative by m over xi, so I get the elasticity of good I with respect to income, and so let me write it down here: the elasticity of good I with respect to income, and see that in this elasticity formula m can either be equal to 0 or greater than 0. So m cannot be negative, it has to be non-negative, 0 or positive. Similarly, xi is giving you the consumption of the ith good. It should either be equal to 0 or greater than 0. So what we are suggesting is that this ratio cannot be negative. This ratio has to be non-negative, equal to or greater than 0. But this ratio can be negative or positive depending upon whether the good is an inferior good or whether the good is a normal good. So if the good is an inferior good, this means that this the derivative will be less than 0, and this means that income elasticity will be less than 0. On the other hand, this derivative will be greater than 0 if the good is a normal good, and income elasticity of the good then will be greater than 0. So this is another way of looking into the classification of normal and inferior good. Normal good will have positive or non-negative income elasticity, and inferior good will have negative income elasticities. So this is first classification that we were interested in. And then we have this second classification, which is preference based, that the goods are defined as the good, or they could be um, defined as bad good. So this is another classification, good or bad good. But then remember that, and this is a sort of warning, that this classification has nothing to do with the changes in income. This classification is totally dependent upon the preferences. Good is a good, more of which when you consume, your utility increases, and bad good is a good, more of which you consume, your utility decreases. So it is associated with the change in utility with respect to the change in consumption of the ith good. If this is a good, so this means that increase in consumption of this good will cause an increase in your utility, and in that case this will be greater than 0. Remember that this is the partial derivative of the utility function with respect to consumption of the ith good, and so you should be able to interpret it as the marginal utility of the ith good. So what we are saying is that a good is good, which gives you positive marginal utility. The marginal utility remains greater than 0 in this particular case. Bad good are the good which decreases your utility. You dislike to consume them, and whenever you are made to consume such goods, then your utility decreases, means that a sort of disutility is associated with the consumption of this good, and the partial derivative of the utility function with respect to the ith good is less than 0, and this is like suggesting that the marginal utility of this good is less than 0. So this is the indicator for a good, and this is the indicator for a bad good. Now see that in the case where we have one of the good as a good and the other one as a bad good. For example, here the indifference curve becomes positively sloped. Here we'll see that good 2 is a bad good, and in this case we'll see that good 1 is a bad good. Just keep in mind that when we are reading the indifference curves, the indifference curve which is further away from the origin represent a higher indifference curve or a higher utility level, and the indifference curve which is closer to the origin is having a lower utility. So first take this first graph and start with, sorry, here assuming that we are keeping the consumption of good 2 constant at a level equal to Q21, and ask the question with same amount of good 2 or keeping consumption of good 2 constant, what happens to your utility when you increase consumption of good 1? And see that when you increase consumption of good 1 in this way, you move from lower to a higher level of satisfaction. So your utility increases, means that this is the case where dava u over dava x1 is greater than 0. If on the other hand you keep the consumption of good 1 constant, like for example at x11, and increase the consumption of good 2, to see that what happens is that you move from lower to from a higher to a lower utility level, and so your utility decreases, and this means that this is the case where dava u over dava x2 actually is less than 0, so good 2 is a bad good. And if you look into the slope of the indifference curves are positively sloped here, but the slope of indifference curve is known as the marginal rate of substitution. So we say that marginal rate of substitution between good 1 and good 2 is greater than 0, is an indication that one of the two good is a bad good and the other good is a good good. Here again see that indifference curves are positively sloped, and let's see that in this case if we keep consumption of good 1 constant, say for example at x11, and increase the consumption of good 2, we move from a lower to a higher indifference curve, indicating that in this particular case dava u over dava x2 is something that is greater than 0. Increased consumption of good 2 causes an increase in the utility. But if we put, for example, consumption of good 2 constant, say at x21, and increase the consumption of good 1, see that what is happening is that we are moving from a higher to a lower and a lower indifference curve. So this means that more consumption of good 1 causes the utility to go down, and this is like saying that dava u over dava x1 is less than 0. Again, because marginal rate of substitution is positive, we see that one of the good is bad good, and in this particular case the bad good is the good 1. So the first indication that one of the good is bad good is that MRS is greater than 0. This is happening in both cases. In this case where good 1 is a good good and good 2 is a bad good, and in this case as well where good 1 is a bad good and good 2 is a good good. So the question is that how can we be sure about that which one of the two goods is a good good? Only MRS greater than 0 is only suggesting that one of the good is a bad good, the other one is a good good. So to see this, look into what is happening to the slope of the indifference curve as the consumption of good plotted along the horizontal axis, in this case good 1, increases. So the slope of the indifference curve becomes smaller, and this is because slope of the indifference curve is marginal rate of substitution. This means that while marginal rate of substitution is positive, it is decreasing with the increase in consumption of good 1. So I could write this derivative the marginal rate of substitution between 1 2 divided by dou x1, and because it is decreasing, when good 1 increases, marginal rate of substitution decreases. So this means that this is less than 0, and so we have the following condition. The first condition is that marginal rate of substitution between good 1 and good 2 is greater than 0, and the second condition is that the change in marginal rate of substitution with respect to consumption of good 1 is less than 0, and when this is the case, we know that good 2 is bad good. So x good 2 is bad. Let us write it here. Good 2 is bad. The good that has been plotted along the vertical axis is bad good. See that we did not bring into our discussion here the concept of income, and this is what that you need to keep in mind, that this classification is totally independent of income. It is only preference based. So the commodity that has been plotted along the vertical axis is a bad commodity if these two conditions are satisfied, that marginal rate of substitution is greater than 0, and the derivative of the marginal rate of substitution with respect to good 1 is less than 0. Now come to this graph and take any indifference curve like the lowest one, and see that what is happening to the margin rate of substitution as we increase the consumption of good 1 here. So we have the second condition, partial derivative of margin rate of substitution between two goods decreases with the increased consumption of good 1. So here this is something that is greater than 0. In fact, margin rate of substitution increases with the increased consumption of good 1. So here we have both things greater than 0, and whenever this is the case, so this means that the commodity that has been plotted along the horizontal axis is a bad good. So good 1 is bad. So we can write that good 1 is bad. Its consumption increases, utility decreases, and then this is something that is happening ceteris paribus. So this is the end of our first segment. You must keep in mind how we have classified these goods into inferior and normal good, and into good and bad good. For the later discussion, the classification of the good into into normal and inferior good will be used in a greater extent. All right. Let us now turn to the decomposition of the price effect into income and substitution effect. Before we go into this discussion, we must have a general idea that why we actually are interested in this decomposition. When price of a good changes, remember, like for example increases in a ceteris paribus way, its quantity demanded may decrease or increase, or even it may remain constant. We want to understand the conditions which can explain in what way the quantity demanded may change following change in the price of a good, so that we could elaborate the causes of such change clearly and make meaningful inferences. In this discussion, we look at the topic through the increase in price of a good But remember that similar explanations could be constructed for any ceteris paribus price changes, and you must practice this area by increasing or decreasing the price of the wood, for example, that has been plotted along the vertical axis, and also by decreasing the price of the wood that has been plotted along the horizontal axis. The first thing to understand is that as the price of a good increases, its expensiveness relative to the other goods, especially the substitute goods, increases, or equivalently, its cheapness relative to the substitute good decreases. Side by side, an increase in price of a good decreases the purchasing power of the household. This means that any change in the consumption of the good of which the price has changed is partly because of the loss in purchasing power, and partly it is because of the fact that the household realizes that the relative expensiveness of the substitute good has decreased, or the relative cheapness of the substitute good has increased. This fact alone can have a bearing upon the consumption decisions of the household, and so at least partly the changes in the consumption basket could be attributed to such assessments of the relative prices by the household. Such changes in consumption, which are solely because of the differences in relative prices, go by the name of the substitution effect. Part of the changes in consumption that occurs because of the loss in purchasing power only is known as they are known as the income effect. If we can quantify these components of income effect and substitution effect, we can explain the total effect of a price change and infer with greater confidence that how the consumption of a good might change following a ceteris paribus increase in price of a good. The easiest way to do this is to compensate the household for the loss in purchasing power when the price of a good increases in a ceteris paribus way, and look into what happens to the consumption basket in question. If the loss in purchasing power is fully compensated for, then any change in consumption that occurs will be totally because of the changes in the relative prices, that is because of the substitution effect. When we have isolated the substitution effect, then from the total effect we could subtract the substitution effect to see that to what extent the changes are only caused by the income effect. Alright, having said all this, let's now look into this graph where I have plotted the consumption of good 1 along the horizontal axis and consumption of good 2 along the vertical axis. This is initially the budget constraint, and that this budget constraint and one of the indifference curves are tangent to each other at point E1, with respect to which we define the initial optimum point. See that individual is consuming x 1i units of good 1 at this point. Then suppose that everything is constant, price of good 1 increases, so that the budget constraints swells inward with vertical intercept same, horizontal intercept shrinking because of the increase in price of good 1, and that along this second budget constraint, one of the indifference curve is tangent at point E3, and with respect to this new tangency point we define the final outcome of this increase in price, which is x1f. As we reasoned that this change in consumption of x from x1i to x1f is partly because of the fact that with the increase in price the household has lost some of its purchasing power, and partly it is because of the fact that the relative prices of good 1 and good 2 have changed. To decompose the income and the substitution effect, to decompose the price effect into income and substitution effect. Now we need to give sort of compensation to the individual, and this compensation should be of the nature that that after compensation the household is just able to consume the previous consumption bundle. So like we are saying is that we are trying to make sure through the compensation that the household is able to attain the purchasing power that was lost. So see that when we provide that compensation, the compensated budget constraint must be passing through point E1, and when this is happening, this means that the household can still consume the same consumption bundle, that is E1. So this compensation, which is represented by the budget constraint in blue, allows the individual to consume x1i units of good 1 and the initial amount of good 2 as well. But see that along this blue or compensated budget line, we have a few combinations of x1 and x2 which are superior to the consumption combination that is available at E1, for the reason that these consumption combination are lying above the indifference curve, which is having a utility level equal to U1. So if these consumption opportunities are available to the household after compensation, definitely household will choose one of these opportunities, and the particular opportunity will be the one where one of the indifference curve is tangent to this compensated budget constraint. And when this happens, you see that the consumption of good 1 that is happening at this particular point is equal to x1s. So we observe that even when the loss in purchasing power of the household is just compensated for, there is a possibility the household may decide to change the consumption of good 1 and good 2 in the way that the household decreases the consumption of good 1 and increases the consumption of good 2. Remember that good 1 is the good of which the price has increased. So this is like saying that the movement from E1 and E2 has nothing to do with the change in purchasing power. So this movement can only be attributed to the differences in the relative prices of good 1 and good 2 along this blue budget constraint and along this initial budget constraint. Along the blue budget constraint, the purchasing power is still the same as the initial budget constraint, because the household can consume this initial combination. But then see that this blue budget constraint is like having a higher relative price of good 1 compared to this budget constraint that was initially available to the household. So we see that the substitution effect actually is telling us that when the relative price of a good increases, the consumption of that good decreases, even when the compensation has been given to the extent that the original consumption combination could be consumed. So this is then what that defines your substitution effect. Substitution effect tells us that in the case of increase in price, if even the price is compensated for, the consumption of the commodity of which the relative expensiveness has increased or relative cheapness has decreased, the consumption of that commodity will actually be going down. And this is what that we are observing here when this consumption goes down from xi to xs. Now see that if we talk in terms of the total change, it was from xi to xf, and from xi to xs is your substitution effect. So as a result of substitution effect, while you move from here to here, and if I take the compensation back, the withdrawal of this compensation actually brings us back to this uh, second budget line, and this is something that is like saying that movement from E2 to E3 is associated with a decrease in income. This blue budget line and this budget line 2 actually are identical in terms of relative prices, but they are different in terms of purchasing power or income. So what we are observing here, that as we move from point E2 to point E3 is like moving from a higher income constraint to a lower income constraint. And when this happens, the result is that the consumption of X goes down from X1S to X1F. So this change in consumption from X1S to X1F has nothing to do with the change in price, because the budget constraint is shifting in a parallel fashion, and so we say that this is only because of the income effect. So this is your income effect. Then we can say that the total effect, which is from x1i to x1f, has two components. A component of the substitution effect, which is from x1i to x1s, and an income effect, which is from x1s to x1f. And the other thing that you should be able to see in this graph is that a movement from E2 to E3, like we said, that it is from a higher income constraint to a lower income constraint. So the income is decreasing while moving from E2 to E3, and with the decrease in income, we observe that the consumption of good one decreases from X1F to from X1S to X1F, and so we can say that change in income is less than zero because income is going down, and change in consumption is also less than zero because consumption of good one is decreasing. So change in consumption of good one is also less than zero. Sorry, change in consumption of good one is less than zero, and this is something that tells us that both changes are having the same direction of motion. A decrease in income causes a decrease in consumption of good one, and this is like saying that dava x1 divided by dava m is something that is greater than 0, or you could write it as delta x1 divided by delta m, because both numerator and denominator are positive, so the ratio will be greater than 0. This is then is saying that in the case of normal good, because this is how we define the normal good, both income and substitution effect implies that the consumption of good one decreases, and whenever this is the case, we know that the demand for good one will be decreasing unambiguously. Partly the decrease in the demand for good one is because of substitution effect. Remember again that partly it is because of the income effect, and it is for this reason, remember, that we say that when we draw the demand curve for normal good, we see that this demand curve is downward sloping, and then we can explain that why this demand curve is downward sloping. Here x1i units of good one, and here we have x1f units of good one, see x1f units of good one, and this entire change is partly because of the substitution effect, and partly it is because of the income effect, and so the demand curve is downward sloping, partly because of the substitution effect and partly because of the income effect. Now, like I said, that in the case where the good in question is a normal good, if its price increases, unambiguously the demand for the quantity demanded of that good will be decreasing. This is something that is true for normal good. Whenever the price of a normal good increases, quantity demanded of that good decreases unambiguously, partly because of income effect and partly because of the substitution effect. Now compare this situation with this second one, where again I have plotted the initial budget constraint a little bit flatter, having a tangency with one of the indifference curve at point E1, where when the individual consumes good 1 and good 2, the consumption of good 1 is equal to x1i, and that then the price of good 1 changes, it increases, so that the new budget constraint with a higher price of good 1 and with the same income level and with same price of good 2 is this brown one, and that on this new budget line or income constraint, the tangency condition is satisfied at E2. So this is the optimum point after the price change, and at this optimum point the household is consuming x1 f units of good 1. Again, the total consumption is equal to total change is from x1i to x1f, and then we compensate the individual, this time not for the loss in purchasing power, but this time the compensation is to the extent that the household is able to get back to the previous level of satisfaction. And when this type of compensation is given, see that again we find that the because of the difference in the relative prices of good 1 and good 2, the substitution effect implies that consumption of good 1 decreases, and similarly the income effect implies that the consumption of good 1 decreases, and so this is your substitution effect and this is your income effect. The difference between these two graphs is that here the compensation is up to the extent that the household is just able to arrive back at the previous level of satisfaction, and in this particular case the compensation was to the extent that household was able to consume the previous consumption combination. So this is known as the purchasing power maintaining compensation, and this other one is known as the utility maintaining compensation. This purchasing power maintaining compensation was the concept that was used by Slutsky, and it is because of this reason that this movement from E1 to E2 is often known as the Slutsky substitution effect. So Slutsky substitution effect is something that is associated with Slutsky compensation. In this case, in the second case, this scheme of compensation which maintains the previous level of satisfaction of the household was presented by Hicks, and it is for this reason that this compensation is known as the Hicksian compensation, and associated substitution effect, which is like the movement from E1 to E2, is known as the Hicksian substitution effect. So this is your Hicksian substitution effect, and the first one was the Slutsky substitution effect. We will be discussing this concept further, but this time with in the context of Hicksian substitution and income effect. For this is the type of explanation which is generally given in the text, but then remember that the conclusions are the same, that Hicksian substitution as well as the Slutsky substitution implies that compensated price change decreases the consumption of the good of which the price has increased. Now, having these things in mind, let's look into this second graph, where we again have the initial budget constraint in black, and this budget constraint is tangent to one of the indifference curve at point E1, with respect to which we see that household consumes x1 I units of good 1, and then the price of good 1 increases so that the budget constraint becomes steeper with the same vertical intercept and horizontal intercept changing. That as a result of this increase in price of good 1, see that the equilibrium moves from point E1 to point E2, and again the total effect is saying that the consumption of good 1 is sorry, this is point E3. The total effect is saying that the consumption of good 1 decreases from x1i to x1f. However, this is a little bit different case from the previous one, in the sense that when you give compensation which is just able to maintain the previous level of satisfaction, see that the new equilibrium along the blue line, budget line, occurs at point E2, and that with respect to this tangency point, we find that the household now consume x1 as units of good 1, and so the substitution effect is as it was in the previous case. And now go into the second round, take the compensation back. It is like moving from a higher budget constraint to a lower budget constraint, and see that when you do that, your new equilibrium is at point E3, which is on the right hand side of point E2, which indicates that when compensation is withdrawn, that is when income of the household decreases, the consumption of good 1 increases. So change in income is like in this case less than 0, and change in consumption of good 1 is greater than 0, because consumption of good 1 is increasing from x1s to x1f. So when we take the ratio delta x1 divided by delta m, we find that this ratio in fact is less than 0. Numerator is greater than 0 and denominator is less than 0, or in other words you can say that dava x1 over dava m is less than 0, and this is something that is saying that a good 1 in this particular case is a normal good, is an inferior good. So what we observe here is that in the case of inferior good, income and substitution effects actually are moving in opposite direction, while substitution effect is still saying that the price of the good, the quantity of the good of which relative price has increased will be decreasing in consumption despite the compensation, whatever is the nature of compensation, Slutsky or Hicksian, and that so the substitution effect is still implying a decrease in consumption of a good 1, but the income effect actually is implying an increase in consumption of good 1. So for example, this was equal to 100 initially, and that the final effect is that you move from 100 units of consumption of good 1 to say 90 units of consumption of good 1, and that when you give compensation, you find that the consumption of good 1 is equal to 80. So from 100 to 80 is equal to your substitution effect, and from 80 to 90 is your income effect. So 90 is the final value, 80 is the initial value. So effect is saying that consumption of X will be increasing by 10 units. In the context of substitution effect, 80 is the final value, 100 is the initial value, and that the substitution effect is saying that the consumption of good 1 will be decreasing by 20 units. So substitution effects and income effects are actually moving in opposite direction, and it is for this reason that we see that the consumption of good 1 decreases, however not to the extent as it was decreasing in the previous case, where the good 1 was the normal good, and see that here what actually is happening is that while substitution effect is calling for a decrease in consumption of good 1, income effect actually is like a sort of diluting the substitution effect. The magnitude of income effect here is less than the magnitude of the substitution effect, because substitution effect dominates, so we observe a net decrease in the consumption of good 1. A little bit different is this case, where again same things have been plotted. E1 is the initial point of equilibrium, and that after an increase in price of good 1, we find that we are along this brown budget constraint, but see that the tendency now is occurring at point E3. At point E3, we observe that the consumption of good 1 actually has increased from Xi to X1F, and this is like saying that the good is a little bit very inferior. See that the substitution effect, which is associated with point E2, indicates that the consumption of the good of which the price has increased will be decreasing after compensation. So substitution effect is still saying that price and consumption of the good of which the price has increased will be moving in opposite direction. The income effect is saying that when you take away the compensation from the individual, see that the equilibrium moves from point E2 to point E3, and this is like saying that the consumption of good 1 increases after the income goes down. So moving from E2 to point E3 is like moving from a higher to a lower budget constraint, and the result in terms of good 1's consumption is that consumption of good 1 increases, and again we observe that change in income and change in consumption are moving in opposite direction, so that DAWA x1 divided by DAWA m is something that is less than 0. Here again the good is inferior good, but then we see that in this particular case income effect that is causing an increase in consumption of good 1 is dominating the substitution effect, and so the net effect is the one that is caused by the income effect, and as a result we observe that the total effect is from x1i to x1f. And this was that is the difference between this second case, where the magnitude of substitution effect is greater than the magnitude of income effect. So this is your income effect. So see, in this case what is happening is that substitution effect and income effect move in opposite direction, with the magnitude of substitution effect greater than the magnitude of income effect. This means that the tendency associated with substitution effect will be dominating, and so we observe a decrease in consumption of good 1. This is what that is implied by the substitution effect. In this case, we see that again the substitution effect and income effect are moving in opposite direction, but see that income effect is dominating this time the substitution effect. So income effect will be causing an increase in the consumption of good 1 to the extent that at the final point the household ends up consuming amount of good 1 which than the one that he was consuming before the price change occurred. So both are the cases for the inferior good. Income and substitution effect moving in opposite direction, with income effect greater than substitution effect, consumption of good 1 increasing, and in this earlier case income effect and substitution effect moving in opposite direction, but substitution effect dominating the income effect, and this means that the consumption of good 1 will be decreasing. Remember that we are talking in the context of an increase in price of good 1. If we revisit these cases in terms of the demand functions or demand curve, see here again we will have the reason to conclude that the demand curve will be unambiguously negatively sloped in the case of normal good, because both income and substitution effect will be causing a decrease in consumption of good 1. So if I plot good 1 along the horizontal axis and price of good 1 along the vertical axis, so if this was your initial consumption point where you're consuming xi1 units of good one. Then see that as price increases, say for example P1 to P1 dash, what happens is that partly consumption decreases because of substitution effect, and partly it decreases because of income effect, and so we observe a demand curve which is a little bit flatter. In this case, where income and substitution effects are moving in opposite direction, see if we plot the demand curve, still the demand curve is downward sloping, but it is less flat, or it is relatively steeper, because while substitution effect is saying that consumption of good one will be decreasing, income effect says that it will be increasing, and so it makes the demand curve a little bit steeper. So here the demand curve becomes steeper. It is still, however, downward sloping. So in the case of inferior good, again the demand curve can be downward sloping. Can be, remember, can be downward sloping, and this is something that is happening because the magnitude of income effect is less than the magnitude of the substitution effect. If we plot this price quantity demand relationship for this third type of good, so we see that income effect, because it's dominating on the substitution effect, the demand curve actually will be becoming positively sloped, so that initial consumption is equal to x1i, and final consumption is equal to x1f. So in the case of this type of good, the Martian demand curve is upward sloping, and this is the case where both these effects are moving in opposite direction, with income effect dominating the substitution effect. So remember one thing, and it is that in the case of normal good, while demand curve is unambiguously downward sloping, because the two effects are reinforcing each other. In the case of inferior good, both possibilities exist. Like here, when the demand curve is downward sloping, it is a little bit steeper though, and in this case where the demand curve is upward sloping, so we can say that if the good is an inferior good, any possibility exists. So there, we really cannot say with certainty what is going to happen to the demand, but we can explain that the demand curve can be downward sloping under the situation where substitution effect dominates the income effect, while these two effects are moving in opposite direction. And if it is not the case, if income effects are greater than substitution effects while they are moving in opposite direction, the demand curve could be positively sloped. So in the case of inferior good, the slope of the demand curve is a little bit ambiguous. It could be positively sloped, it could be negatively sloped. So this is something that is true about the income and substitution effect, both in the case of normal and in the case of inferior good. This one where the commodity is so inferior that its demand curve becomes upward sloping. Marshallian demand curve, in fact, becomes upward sloping. This is something that is known as the case of the Giffen good. You know this concept probably from your previous courses in microeconomics. So that is Giffen good case, where income and substitution effects move in opposite direction, with income effect dominating the substitution effect, and thereby causing an increase in the consumption of a good of which the price has increased in terms of total consumption. This is something that is true about the income and substitution effect in the case of good one of which the price had increased. Now remember that this decomposition of price effect into income and substitution effect could be done in terms of good 2 as well, when the price of good one increases. So I have redrawn that same graph, but in place of recording the change in consumption in terms of units of good one, this time I am recording the change in consumption in terms of units of good two. So see, again we have this initial equilibrium point E1, and this at this point household was consuming X2 I units of good one, and then price of good, so sorry, X2 I units of good 2, and when the price of good 1 increases, so this brown becomes your budget constraint. See that along this budget constraint, equilibrium is occurring at point E3, where the household now is consuming X2F units of good 2. So what happens is that the consumption of good 2 has increased from X2I to X2F. So this is your total effect, and that when you compensate the household for the loss in real income to the extent that the household is just able to attain the previous level of satisfaction, to see that the new equilibrium occurs at point E3, and we see that at point E2, and we see that the household with this compensation will consume X2S units of good 2. This means that the movement from E1 to E2 is in fact the substitution effect, but this time we are not measuring substitution effect in terms of good 1, we are measuring substitution effect in terms of good 2 when the price of good 1 has changed. So because the good of which the price has changed is other one, and the good in terms of which we are recording the changes in consumption is the second one. So sometimes remember that this type of substitution effect often is known as the cross substitution effect. So cross substitution effect, when we are decomposing the price effect into income and substitution effect using the consumption of the good of which the price has not changed, price of the other good had changed, and we are recording income and substitution effect in terms of the consumption of the other good. Now see that from E1 to E2, your substitution effect, which was saying that consumption of good 2 will increase from X2I to X2S, and that from E2 to E3 is your income effect, and see that when this is happening, we say that the income effect is something that will bring you down from X2S to X2F, so consumption of good 2 rather will be decreasing as a result of income effect. Now see that in terms of substitution effect, consumption of good 2 increases. In terms of income effect, the consumption of good 2 decreases. And in this particular case, when we observe that when we move from point E2 to point E3, this is a movement from a higher income constraint to a lower income constraint, and then we can conclude that as income decreases, consumption of good 2 decreases from X2S to X2F, and so this means that we can conclude that dava X2 divided by dava M is something that is greater than 0. That is, when income decreases, consumption of good 2 decreases as well. So good 2 is a normal good in this particular case. So this is what that is the story of decomposing the price effect into income and substitution effect. Now, after having this understanding of the decomposition of the price effect into income and substitution effects, we are in a position to discuss one of the important result in the context of consumer theory, and that is the Slutsky equation. And we will derive this equation using this first graph that we had drawn earlier, where we had decomposed the price effect into income and substitution effects using the Slutsky compensation. Keep in mind that Slutsky equation is nothing different than the decomposition of the price effect into its two effects, that is the substitution and the income effect. The only difference is that previously we saw it in terms of the total changes in consumption of good one, for example, caused by a given change in the price of good one, or the total change in consumption of good two, following a given change in the price of good one. Here, in the Slutsky equation, we see the same decomposition of the price effect into income and substitution effect, but in terms of per unit change in the price of any good, and this what that is actually the Slutsky equation. So starting with say point E1, which is this one, the initial budget constraint, the black one, is tangent to the indifference curve at point E1, with respect to which initial quantity of consumption is equal to x1i, and that when price changes, the budget constraint move inward with same vertical intercept, horizontal intercept going down, and you see that the equilibrium, the final or the new equilibrium, occurs at point E3. Just keep in mind that along the first budget constraint, let us say price of good 1 was equal to P1, price of good 2 was equal to P2, and income is equal to M1. That then price of good 1 only changed, say from P1 to P1 dash. Price of good 2 has remained unchanged. Similarly, income has remained unchanged. This is something that is happening along the brown budget constraint. And the first combination is with the black budget constraint. And so we see that the equilibrium moves from E1 to E3. So this is the total change, where the household now is consuming x1f units of good 1. So total change is equal to x1f minus x1i, and this first equation actually is representing this total change. So total change when price of good 1 changes from P1 to P1 dash. So P1 dash minus P1 actually is the total change in price, and when this change occurs in the price of good 1, the associated total change in consumption of good 1 is equal to x1f minus x1i. Then we give a Slutsky compensation to the household so that the compensated budget constraint passes through point E1, ensuring that the household's purchasing power is restored to the extent that the household is just able to consume the commodity bundle which he or she was consuming before the price change occurred. And that along this compensated budget constraint, which is blue one, so what we have done is that we have increased the income of the individual, the money income of the individual. So along the blue budget constraint, P1 dash is the price of good 1, P2 is still the price of good 2. Income has moved up from M1 to M2, so compensation is equal to M2 minus M1. So this is your Slutsky compensation, and this we are saying is equal to the change in M to bring the budget constraint at a position so that it is the blue one. And we see that along this blue budget constraint, the utility maximizing combination is represented by point E2. So as a result of compensation, consumption of good one increases from X1F to X1S, and so this is happening because of the change in income from M1 to M2, and so we say that this is a kind of income effect, and this is the equation 2, which represents this income effect. Final value of consumption after compensation is X1S. Before compensation, the household consumes at point E3, so that initial here the consumption was X1F. So from X1S we subtract the amount X1F to see that by how many units consumption of good one changes as a result of this compensation. And so this is something that is happening due to the change in income. So we could safely say that this is an income effect. Then we once have isolated as the outcome after compensation, we can understand that the substitution effect is from E1 to E2, the substitution effect, and this is this third equation which is giving us the substitution effect. And then we can write the equation that total effect is equal to, or say, change in consumption due to total effect is equal to change in consumption due to substitution effect, which is X1S minus X1I. And from this change, when we subtract the income effect change, which is X1S minus X1F, so X1S will get cancelled and we'll be left with X1F minus X1I. So this is the typical decomposition of the price effect into income and substitution effect that we saw earlier during this presentation. Now in the next step, we have divided this total change on both sides of the equation by the change in price of good one, and when we do this, to see that this term on the left hand side becomes total change in consumption of good one for per unit change in the price of good one, and on the right hand side this first term becomes the change in consumption of good one due to substitution effect per unit change in price of good one, and similarly the last term is change in consumption of good one due to income effect per unit price change in the price change of good one. And the way that I was pointing this thing out earlier, that Slutsky equation is nothing more than the expression or decomposition of the price effect into income and substitution effect in terms of per unit price change of a commodity, in this case commodity 1. Now what we have done in this later equation is that we have divided and multiplied the last term by delta m, so the equation still remains unchanged, and then we have rearranged it a little bit so that we have these two terms. When we look into these terms separately, we will be able to interpret them as well. To understand this these terms, see that we'll be using this numerical example where these are the initial prices and income of the individual, and with these prices and income, individual is consuming 100 units of good 1 and 50 units of good 2. And so see that when the household consumes 100 units of good 1, so this means the expenditures on good 1 are equal to 5 multiplied by 100 equal to 500. And when at the price of rupees 10 per unit, the household consumes say 50 units of good 2, again the expenditures are equal to 500, so that the budget constraint is just satisfied. Then we see that the price of good 1 increases from rupees 5 to rupees 10, and that if we still want to consume 100 units of good 1, then this means that the needed expenditures on good 1 at new prices will be equal to 1000, because price of good 2 has not changed. So this means that the needed expenditures on consuming 50 units of good 2 remains unchanged, and so they are equal to 500. And this means that this same combination of good 1 and good 2 could only be consumed if the individual has an income equal to 1500, and then this means that the Slutsky compensation is equal to 500. So this is the change in income that is required to allow for the consumption of the commodity basket that the household was consuming before the price change occurred. We have like a little bit written these same things in terms of equations to arrive at a general result. So see that change in income that is needed actually is equal to the expenditures with the new price of good 1 minus the expenditures of with old price of good 1. This is the same thing as 1000 minus 500 here in this numerical example. And see that because we are keeping the consumption of good 1 same, so we can take this thing as a common out from these two expressions, and we are left with this difference in price, which is now equal to delta P1. And so we have delta M equals to delta P1 times X1, and when we solve it, we get X1 equal to delta M over delta P1. That is when the price of good 1 changes by 1 unit, like for example 1 rupee. So this is the change in income that is needed to consume X1 or same or previous consumption, the amount of good 1. So this is something that is not surprising, and because delta M over delta P1 is equal to X1, so in place of delta M over delta P1, we can write this amount, this quantity X1, or the Marshallian demand function. And this result that now we arrive at is actually known as the Slutsky equation. And see that we have arrived at this result using Slutsky decomposition. So this is your Slutsky equation. If we try to interpret it, this is the same thing. The total change in consumption of good 1 per unit price change of good 1, total change in consumption of good 1 per unit price change of good 1 due to substitution effect, minus total change in consumption of good 1 per unit price change of good 1 due to income effect. You see that the Slutsky equation could also be written in the form of the partial derivative. So this is the partial derivative of the total effect with respect to price of good 1. and this is the partial derivative of the substitution effect with price of good 1, and this is the partial derivative of the income effect with respect to income effect, and this is your demand for good 1. See that when we write this equation for the Hicksian compensation, so this means that utility is held constant, and then this is like the movement along the same Hicksian, along the same indifference curve, and it is like movement from point E1 to E2 in this graph, and because we are moving along the same indifference curve, this means that point E1 and E2 both lies on the Hicksian demand curve, and point E1 and point E3 they lie on the Marshallian demand curve. So this equation then actually is telling us that for a price change, this is the slope of the Marshallian demand curve on the left hand side of the Slutsky equation. This is the slope of the Hicksian demand curve, and this is the income effect. So from the slope of the Hicksian demand curve, when we subtract the income effect, we get the slope of the Marshallian demand curve. In this discussion, see that we have been looking into the changes in consumption of good 1 when price of good 1 changes, and for this reason this equation is often known as the Owen-Slutsky equation, and we can then say that the Owen-Slutsky equation implies that the Marshallian demand curve can slope downward or upward depending upon the signs of these terms that are appearing on the right hand side of this equation. If we look into this first term on the right hand side, we have reason to believe that this is non-positive, so it should either be less than 0 or equal to 0, and that this term on the right hand side is it can be both greater than 0 and less than 0 depending upon whether the good is a normal good or inferior good. Then we need to prove actually that this is something that is less than 0 or equal to 0. If we assume strict quasi-concavity, then it is strictly less than 0 in fact, and we had seen that the reason for that is that this slope of the action demand curve is the second derivative of the expenditure function. So if you recall that we had written expenditure function as a function of utility and prices, utility if is held constant and other prices are held constant, and then we take the derivative, partial derivative of the expenditure function with respect to P1, we in fact get the Hicksian demand, and that is something that is Hicksian demand function. So let us write it down as XH. And if we take the second derivative of this equation, dou square E over dou square, dou P1 square, so this will give us the slope of the Hicksian demand curve in fact, and that will be dou x1h divided by dou P1. This first derivative actually is the property that we had seen in the name of Shepard's lemma, And when we were doing expenditure function, we had seen that for a strictly quasi-concave utility function, expenditure function was strictly concave, and this means that the slope of the expenditure function was continuously decreasing while expenditures were increasing, and this is something that follows because of the optimization behavior of the household. And given that this derivative is strictly less than zero for for strictly quasi-concave utility function, means that this term is negative. Given that this second term, dava x1 over dava m is greater than 0, this is positive, and when this positive sign combines with this negative sign, so we get a negative sign, and so this means both term on the right hand side will be negative. Of course, this is the Marshall demand function, and for any income and price combination, this either must be equal to 0 or greater than 0, so it cannot be negative. This is something that is in line with the fact that if the good is a normal good, then the Marshall demand curve will have a negative slope, and we had seen it earlier that in this conclusion there is no ambiguity involved. Then if the second term, this derivative is less than 0, this negative sign combines with this negative sign to become positive, and so we have a positive quantity on the right hand side and a negative quantity, and that what is going to be the slope of the Marshall demand curve will actually be depending upon whether the positive magnitude is greater than this negative magnitude in absolute terms, or vice versa. So for example, if this is like equal to plus 2 and this is like equal to minus 5, then see that the slope of the Marshallian demand curve will be negative, and so we can conclude that if the good is an inferior good, then still there is a possibility that Martian demand curve will be negatively sloped. But if the positive magnitude is like greater than the negative magnitude of the substitution effect, then the income effect or positive effect will be dominating, and in that case we will be having the Marshall demand curve with the positive slope. So with the inferior good, Marshall demand curve can have a negative slope or it can have a positive slope, depending upon whether the income effect dominates the substitution effect or vice versa. And see that these same results we had seen earlier when we were decomposing the price effect into the two components, income and substitution effects. So on Slutsky equation is like telling us that the slope of the Martian demand curve can both be negative and positive, that it will be negative in the case of normal good, it can be negative even in the case of inferior good when the magnitude of income effect is less than the magnitude of substitution effect in absolute terms, and it can be positively sloped when in absolute terms the magnitude of income effect is greater than the magnitude of the substitution effect. So this is true about the Slutsky equation, where we were looking into the change in consumption of the good of which the price had changed. If we change the things a little bit and see that what is going to happen to the consumption of good 2 when price of good 1 changes, so that is something that is like talking in the context of the cross substitution effect that we had seen earlier. To arrive at the Slutsky equation, we follow the same steps. So total change in consumption of good 2 when price of good 1 changes is equal to the change in consumption of good 2 due to substitution effect, and from that we subtract the change in consumption of good due to income effect. That is something that we have noticed earlier when we were looking into the cross substitution effect. See that after the exchange compensation, what happened was that we moved from point E1 to point E2. Consumption of good 2 increased from X to I to X to S, and that when compensation is withdrawn, we move from point E2 to point E3, and in this case we observe that movement from point E2 to point E3 is a movement from a higher income constraint to a lower income constraint, and so as income decreases, we observe that the income effect implies that consumption of good 2 decreases, and this is something that is suggesting that good 2 is a normal good. So if we look into this cross substitution effect is telling us that the consumption of good 2 increases, and the income effect tells us that the consumption of good 2 decreases, and again we see that the two effects are moving in opposite direction. This is something that is happening, and then it is because of this reason that when we are talking in the context of the cross Slutsky equation, so see that this is like saying that this is a positive, this is going to be positive, and this is something that is going to be positive or negative. So income effect can have a negative impact or positive impact. So positive impact is where the good is a normal good. So if good 2 is a normal good, so this is something that is going to be positive. And then we have this um, cross Slutsky equation written in terms of the delta terms. So delta x2t divided by delta p1 equals to the delta x2s divided by delta p1 minus delta x2m divided by delta p1. Same steps are involved. So this is per unit change, total change in consumption of good 2 for per unit change in price of good 1. This is the change in consumption of good 2 due to change in due to substitution effect for per unit change in price of good 1, and this is change in consumption of good 2 because of income effect for per unit change in price of good 1. So this is also delta, and then we have followed the same steps, divided and multiplied this equation by delta m, and then rearranged the terms a little bit, and then see that this delta m over delta p1 we have already seen is equal to x1, and so in this way we are able to obtain the cross Slutsky equation. The partial derivative form, in partial derivative form it could be written like this. I have skipped some of the steps to arrive at the action version of the Slutsky equation, or cross Slutsky equation in fact, and this is like saying that this is something that is greater than 0, this is something that can be greater than 0 or less than 0. Now remember that in the two commodity world, this first term is definitely going to be greater than 0 for the reason that when consumption of good 1 is going down because of one substitution effect, then after compensation consumption of good 2 should definitely be increasing. So whenever this is the case, we say that good 2 and good 1 are net substitutes. So on substitution, cross substitution effect greater than 0 implies that the goods are net substitute, good 1 and good 2 are net substitutes. if there are more than two goods, so there is a possibility that some of the goods might be um, substitutes. Some of the words might be net complements. So this means that as far as this first term on the right hand side is concerned, it could be a positive or it could be negative, depending upon that whether the substitution effect is implying that the consumption of the other good will be increasing or whether it will be decreasing. If the consumption of the other good as a result increases, so this means that this good is a net substitute of the good of which the price has increased, and if this derivative is less than zero, then this means that good 2 is the net complement of the good of which the price has increased. And so first to take the easiest case where both these terms are positive, and then this means that the first term is greater than 0 as well as the second term is greater than 0. So sorry, first term is greater, first derivative is greater than 0 and the second derivative is greater than 0. So this derivative greater than 0 net substitute this derivative greater than 0 means that the good is a normal good, but then this means that this plus sign will combine with this negative sign to become negative, and so we have the first term positive, the second term negative. Then this means that the total effect will be depending upon the relative magnitudes of these two terms, and if substitution effect dominates, then this means that the left hand side will be greater than 0, and in that case we say that two goods are are gross substitutes. The two goods are gross substitutes. You know from your um, previous courses that if the price of good 1 increases and as a result consumption of good 2 increases, then good 1 and good 2 are substitutes. The more precise term now we have in our hand, and it is that they are in fact gross substitutes. And in this particular case, where they are net substitutes, they are also gross substitutes. Now, if it so happens that the good is still normal, but then the income effect dominates, for example, this is equal to minus 5 and this is equal to plus 2, so this will become equal to minus 3, and then we say that when price of good 1 increases, consumption of good 2 decreases. They are known as gross complements, remember. So while the good is a net substitute, then there is a possibility that if that the good might be a gross substitute or it might be a gross complement, depending upon whether the income effect dominates the substitution effect or vice versa. So this is something that is true about the nature of the second good with respect to the price of the first good. So this is an important result that you must keep in mind, that while the two goods could be net substitutes, then simultaneously they could be gross substitutes or gross complements. If this term is like a negative, that is, if the good in question is inferior good, then this negative sign will be combining with this negative sign, and so it will become positive, and this positive and this positive will ensure that the left hand side is positive. And so if the good is an inferior good, good 2 is inferior good, then this means that while it is net substitute, it is also necessarily gross substitutes. So that is something that is true when the good is an inferior good. So remember that still while the good is good 1 and good 2 are not substitutes, so that this is something that is greater than 0. When this is less than 0, so this negative sign combines with this negative sign to become positive, and so the effect on the second good is positive and gross, and so the second good is gross substitutes. In So see that for further discussion, I have simplified the equations a little bit. In place of writing this entire equation to mention the Martian demand function for good I, I now will be using XIM, and that to mention the action demand functions for good I will be using XIH. So with this notational change, I have written down the entire system of Slutsky equations here in a particular way. See that each row consists of Slutsky equations for one good. So this first row consists of all the Slutsky equations for good 1, and this second row consists of all the Slutsky equations for good 2, and that with the help of these Slutsky equations, I have written down this matrix system. The left hand side matrix in this equation is made up of the left hand sides of these equations. See that I am maintaining the order in the matrix as well. So first element is like coming here, first row first column, and this is second row first column, and this is first row and second column, and this is second row and second column. So on the left hand side, and this is what that actually then has been written here. So this is the matrix of partial derivatives of the Martian demand functions with respect to prices, and let's see that we are maintaining the order in which we had written down these equations in a particular way. See that in this matrix, this first column now consists of all the partial derivatives of the Martian demand functions for good 1 and good 2 with respect to price of good 1, and second column consists of the partial derivative of the Martian demand functions with respect to price of good 2, and if there had been a third commodity, so there would have been a third column as well as a third row consisting of the third column will be consisting of the partial derivative of the Martian demand functions with respect to price of good 3, and so on. On the right hand side, this first matrix is known as the substitution matrix because it is made up of the substitution terms. This is the own substitution effect or the slope of the action demand curve, and see that on the right hand side this is the first element, and that is first row and first element on the right hand side. This is the element in the second row in the first column, and so see that these two effects are like here and here. So all the partial derivatives of the action demand functions with respect to P1, and in the second column all the partial derivatives of the action demand functions with respect to P2, and so on. Then we have written down the income effect matrix, again maintaining the order. So let's see that this is the first element in this matrix, first row and first column, and this is first row and second column like coming here, and similarly is true for the rest of the elements of this matrix. So this is a way of writing this system of Slutsky equation in the matrix form, and then we can put it in a compact format. Before that, we need to little bit modify the system and see that no change has been made on the left hand side. Similarly, no change has been made in the first matrix on the right hand side. The second matrix, the matrix of income effect, has been written in terms of the product of this column vector and this row vector. See that this is the vector of partial derivative of Marshallian demand functions with respect to income, and this is the transpose of the vector of the Marshallian demand function, and that if you may take the product of this vector and this transpose of the Marshallian demand function vector, so you will be getting this last matrix back. So this is another way of writing it, and we want to do it because we wanted to put it in a more compact form, and this is something that we have done here in the last equation. So see that this is the matrix of derivative of the Marshallian demand functions with respect to prices, or so price 1, price of good 1, price of good 2, etc. Similarly, the first matrix on the right hand side is the matrix of derivatives of the Hickshian demand function with respect to price, and this is the vector of derivatives of the Marshallian demand functions with respect to income, and this is the vector of this is in fact the transpose of the vector of the Marshallian demand functions. The reason for writing the system of Slutsky equation in this format is that it can be written for any number of goods. So like for example, n might be 10, 20, 30, whatever is the number of goods, or n, or say n by n. So this will be an n by n matrix having the total effects, and this will be the n by n substitution matrix, and n by 1 column vector of the derivatives of the Marshallian demand function with respect to income, and this will be a 1 by n transpose of the vector of Marshallian demand functions. Before we move further, see that I want to say something about this matrix on the right hand side, which is known as the substitution matrix, for the reason that it consists of all the substitution terms starting from the own substitution effects. We already know that all substitution effects are non-positive, and this means that these diagonal elements are either equal to 0 or less than 0. The reason is that they are the second derivative of the expenditure function. So see that if you had expenditure function as a function of price and utility, and if you take the derivative of expenditure function, for example, with respect to price of good 1, if you take the partial derivative of this expenditure function with respect to price of good 1, so you will be getting the Hickshian demand function for good 1, and this is something that is true because of Shepard's lemma. And then if you take the second derivative of the expenditure function with with respect to price of good 1. So this is like P1 square. So you will be getting like dava x1h divided by dava P1, which is the slope of the action demand functions. Now, this is something that is less than 0. Why? Because when we were studying the expenditure function, we had seen that expenditure function is concave, so that while it is increasing in prices, like for example, if I am plotting expenditures along the vertical axis and price of good 1 along the horizontal axis. So if the utility function is strictly quasi-concave, so we will find that when price of good 1 increases, expenditures will be increasing at a decreasing rate. That is, expenditure function is concave. And when we are saying that expenditure function is concave, it means that while first derivative is greater than 0, second derivative is equal to less than 0, and if it is less than 0, then it is strictly negative, so that own substitution effect is negative, and if it is equal to 0, still we have own substitution effect non-positive. So the diagonal matrix are non-positive, equal to or less than 0, and this is something that is true, as we have shown, because of this property of the expenditure function. If we assume that the underlying utility function is strictly quasi-concave, then these elements in the diagonals are definitely less than 0. So there is no reason to assume otherwise. Now, as far as the cross substitution effects are concerned, we say that cross substitution effects are symmetric, and by this we mean that if we take the partial derivatives of the expenditure function with respect to price, we get the Hicksian demand functions, and then if we take the second derivative of this first derivative with respect to P2, so we get dava x1 h dava P2, and similarly here we get dava x2 over dava P1. See that on the left hand side these two equations are equal because of the Young's theorem. So when the left hand sides are equal, then this means that right hand sides are also equal. So we have this term on the right hand side of the first equation equal to this term on the right hand side of the second equations, but these are cross substitution effects, so we can then say that cross substitution effects are symmetric. And this is something that is true about the substitution matrix. So in total, we can say that this substitution matrix is negative, semi-definite, and symmetric. That is, all these all substitution effects are negative, and these cross substitution effects are symmetric. So we then summarize our conclusions here in terms of these 3 points. One is the Waller's law, that the utility maximization problem or expenditure minimization problems we have that we have at our hand gives us a system of Martian and Hicksian demand function, such that the Martian and demand functions satisfy Waller's law. And this means that if in the budget constraint we insert the Martian and demand function, the left hand side of the budget constraint will be equal to the right hand side. It is like saying that the budget constraint is satisfied at all income and prices. So this is one property of the Marshall and demand functions, that Marshall and demand functions will be satisfying the budget constraints at all income and prices. And then we have this second property which follows from this discussion of ours, that Marshall and demand functions are homogeneous of degree 0 in income and prices, and Hicksian demand functions are homogeneous of degree 0 in prices. We have seen these properties in detail. This last property that now we have seen because of our discussion on Slutsky equation is that the substitution matrix is symmetric and negative semi-definite. That it is a negative definite in the case where the underlying utility function is strictly quasi-concave, and see that it is negative semi-definite means that we are allowing for the possibility that the substitution matrix, substitution effect rather, might be equal to 0, and this is the case when the indifference curves are of Leontief type, so that see that there is no substitution involved. So if like for example this was your first budget constraint, price of good one increased and then you provided the compensation, substitution effect is equal to 0. So there is something that is like true about the properties of the Marshall and Hicksian demand functions, that the last property is something that we are able to see due to our discussion on the Slutsky equation. So this is the end of this discussion. If you have any questions or any doubts or any confusions, you may want to ask me in the class, or probably you may send me an email so that I can answer you, and so that you don't have any confusions, at least at the day of the exam. So let's finish this.